So obviously we have to keep looking more at the regional contributions to global greenhouse gas emissions and global warming. We already looked a little bit at per capita income, per capita greenhouse gas emissions. Extending that a little bit further here, we are looking at regional indicators and regional production versus consumption accounting for 2018, which happened just before the report was to be finalized and released. So this is just a good indication. We are looking at Africa, Australia, Japan, New Zealand in one region, Eastern Asia. So Eastern Asia apparently does not include Japan, which I should be careful about. Also, at the end of the last podcast, I said equal but differentiated responsibility. That's wrong. It is actually CBDR, I think, common but differentiated responsibility. So climate action is a common responsibility, but it's differentiated in terms of who has been historically responsible and who is trying to grow now and becoming bigger and bigger emitters, like India and China, for example. So there is Eastern Europe, Western Central Asia, Europe, Latin America and Caribbean, Middle East, North America, Southeast Asia and Pacific, and Southern Asia. So look at populations, millions of persons. Obviously Eastern Asia, Africa and Southeast Asia have reasonably large numbers. Okay, GDP per capita in US dollars, thousands per 27, so US dollar 1,000 pegged to 2017 per person. Africa is low. This is a rich place. Eastern Asia is somewhere in the middle. Eastern Europe is not as rich as Western Europe. Latin America is not as rich as the Middle East, and North America is of course the richest. South Asia is less than China, for example, and Southern Asia is also somewhere close to Africa. Depends on which countries are included. So net greenhouse gas emissions in 2019 production basis, percentage greenhouse gas contributions, greenhouse gas emission intensity in tons of CO2 equivalent per US dollar 1,000 ppps, purchasing power parity, which is a way of equalizing currency differences across, and we will not get into the details, but let's just say that's a way to compare different countries on a common basis, and greenhouse gas per capita in tons of CO2 equivalent per person. So Africa didn't contribute much, but was more than Australia, Japan and New Zealand. Eastern Asia here is contributing quite a bit because it exports. It's a manufacturing hub for the world. Eastern and Western Europe here, Latin America and the Caribbean. So depends on what is. So North America is contributing 12% in terms of production basis alone. So this goes towards the embedded carbon idea that we talked about before. Southeast Asia and Pacific are contributing 9% and Southern Asia at 8%. Intensity of greenhouse gas depends again. Africa is relatively high compared to, let's say, Europe and North America. Middle East is high because it obviously exports a lot of oil, produces a lot of oil, sorry, and South Asia and Pacific in the similar range, and Eastern Asia also above 0.6. So you can think of why Africa is very high. It depends on what is being exported and how it is being produced. Greenhouse gas per capita, tons of CO2 equivalent per person. Africa is here. Australia, Japan, so Western countries are high. North America is the highest here at 19. Eastern Europe here comes out higher than Europe because of the various lifestyle issues and technology, energy sources, and so on and so forth. So if you look at CO2 from fossil fuel and industries in 2018 per person, production-based emissions, again in tons of CO2 FFI per person based on 2018 data. Australia, Japan, New Zealand are high. North America is the highest. China is somewhere in the middle, and the Southeast Asia and Pacific are here, and Southern Asia is low, but Africa is of course the lowest. So you can see the CO2 emissions here and production-based emissions here, and see how the contributions are different. Okay, so consumption-based emissions in tons of CO2 from fossil fuel and industries per person, based again on 2018 data. Africa is low, and South Asia is almost double of that. Eastern Asia, Australia, Japan, New Zealand are high. Eastern Asia is somewhere in the middle. Eastern Europe here is almost similar to Europe, but North America is twice of that. So lifestyles, production, consumption, everything matter. Looking at unit costs of some forms of renewable energy and of batteries for passenger EVs that have fallen. So we are moving now towards mitigation and how to think about where we are headed in terms of trajectory. So there is the increase in greenhouse gas emissions per capita emissions, production and consumption based emissions, and so on. And now moving towards mitigation, we can start thinking about some positive things. So fossil fuel here has remained constant across 2000 to 2020. So we are looking here at photovoltaics, onshore wind, offshore wind, concentrating solar power, which is mirrors that concentrate the solar powers and heat some fluid like water or oil or something else to store the energy, which can then be released later on, as opposed to photovoltaics, which are using electrons to directly generate electricity. So the prices have dropped in terms of $2020 in per megawatt hour, gone from about 600 in 2000 down towards almost less than fossil fuels by 2020. Onshore wind was already cheap and has gotten much cheaper. Offshore wind remains, but kind of oscillated similar to fossil fuels because of the various construction issues, transportation, transmission of energy, and so on, but has dropped in the last 5 years or so. Concentrated solar, not very widely used like PV, but I think Spain and US are maybe larger than others, and that has dropped down to the fossil fuel level as well. The adoption in terms of gigawatts over the same period has been exponentially growing, especially since 2010. Onshore wind grew a little bit faster than photovoltaic after 2000. Onshore. Offshore has been slow, but has now taken off. But these numbers are very different, so be careful. Here it is 800 gigawatts. Here it's only 40 gigawatts. So we have to remember that as well here. Concentrating solar power is slower and the smallest of all. As I said, it's not very widely used yet, but maybe the dropping costs in dollars per megawatt hour will change that story in the coming years. So there are the market costs and adoption as we looked here, and fossil fuel costs are in this gray bands, and AR5 in 2010 was released and was reporting these numbers, which are shown with this dashed lines, which means AR6 obviously has seen a much better news in terms of renewables. Batteries for passenger electric vehicles, costs again for dollar in 2020 versus kilowatt hours have dropped, and adoption in millions of EVs has grown. These numbers also have to be tempered with the market share. For example, EVs have grown very nicely here, but the numbers are very small in terms of the total number of vehicles sold, and of course the rest are all internal combustion engines, and fossil fuel efficiency is going up, but obviously it's still not as good as EVs. And of course the other caveat for a country like India is that even if number of EVs increase, the way they are going to be charged has to become cleaner as well. Otherwise, dirty power supplying recharging energy to EVs is not going to reduce emissions. So all those transitions have to happen together as well. I'm going to skip this table, which just looks at the various policies and implied NDCs prior to the Glasgow COP26, which happened in 2021. We'll come back and look at this in terms of a curve, which we have already done, in fact, in various other podcasts as emission gaps, where we want to be in terms of global warming targets and where the drawdown has to go, and what the nationally determined contributions implied and how revised contributions will help, and what the policies were by 2010 and how they have changed, conditional NDCs, unconditional NDCs, and so on. Of course, unconditional elements are what countries like India and China will do anyways, and conditional elements are those which will require some financial and maybe intellectual property, technology transfer kind of things to implement under the nationally determined contributions, like the transition from HFCs to more friendly refrigerants, for example. Okay, so those details are presented as graphs which are easier to look at, which I will do in the next podcast. Okay.